In the space of science and tremendous secrets, the subject of what existed beforehand to the massive blast has mixed discussions and captivated characters for a long time. This colossal solicitation doesn't simply test how we could unravel the universe. It challenges the certified furthest limits of human knowledge. Imagine standing at the edge of existence, investigating the titanic shadowing, and contemplating what lay there before our universe was envisioned. The event of the Big Bang marked the dawn of mankind, space, and all that we know. In any case, was there a moment sooner, beforehand this might? Could there have been a state of nothingness, a quiet before the grandiose gathering began? And if this is valid, was it? Or maybe there was something substantially more disturbing that existed beforehand, before time itself. As we delve further into this question, science takes us on an excursion beyond the universe's starting point into considerations that challenge our consciousness. Physicist Brian Cox, known for his insight into the miracles of the universe, proposes that something astounding could have existed before the Big Bang. He moves us to re-examine our thinking of reality and existence. In this assessment, we'll take apart the science, the theory, and the stunning insider secrets that could figure out what existed before all that. We'll explore considerations like bombastic expansion, quantum changes, dark energy, and even multiverses. The responses we've uncovered may very well incapacitate you, but they could also open new understandings of our situation in the universe. Prepare to jump deep into a world beyond imagination and science, where the dark still twists around the shadows, leaving researchers stunned and sometimes even baffled. Let's explore what existed before the Big Bang and why these hypotheses challenge all that we assumed we knew. To appreciate what might have existed before the Big Bang, we first need to meticulously dissect what the Big Bang truly was. The Big Bang, as scientists define it, refers to the moment when the universe became very hot and dense, rapidly expanding to trigger the development of all matter, energy, and the forces we see. When we look toward the night sky, we see evidence of this hot start, with galaxies fanning out from a singular starting point. However, why did this happen? Besides, was there a time before this thick, hot beginning? As shown by the theory of great expansion, there was undoubtedly a before, and it was way off the mark to void or tranquil. Great expansion suggests that before the Big Bang, the universe was in a state that was cold, empty, and free, basically like a gigantic vacuum. Yet, this vacuum wasn't completely unfilled. It contained an enormous amount of energy that fueled the rapid growth of space itself. This expansion, called inflation, occurred so quickly that it essentially set the stage for everything that would follow. The expansion stretched at unimaginable rates until the expansion slowed down, and the energy turned into matter particles and the forces we see as the Big Bang. But what was the nature of this energy? Why did it suddenly develop the universe? And why did it stop? Experts believe that this boundless expansion created patches of the universe, each experiencing its own Big Bang. Imagine a fabric extending endlessly, with tiny air bubbles forming from time to time. Each bubble represents a universe, including our own. This thought, called the inflationary multiverse, suggests that there are potentially boundless Big Bangs and a limitless number of universes. Our own is merely one of many. This gigantic, mind-bending reality challenges how we might understand the very universe itself and leaves us with the question, what else is out there? The possibility of nothingness before the Big Bang is speculative, not real, at least per our current understanding. Whether or not you remove all energy, particles, and radiation from the universe, it would still not be truly void. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that weave an inevitable, woven fabric of something, even in its most empty design. Even if we imagine stripping away these forces, leaving a dead space, the universe would still generate new kinds of energy. This reality alone is baffling to experts, as it suggests that true nothingness may be impossible within our limitless understanding. Space itself has properties, rules, and constants that prevent it from being completely empty. Imagine creating a region with virtually nothing in it, no particles, no radiation, and no energy, except for quantum fields and fundamental constants. These would still exist, suggesting that this nothingness has properties. For example, there's a characteristic called zero-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can still momentarily appear and disappear, creating a creepy echo of activity even in what should be empty space. This challenges our concept of a true void and suggests that, yes, even before the Big Bang, there was something scientists are just beginning to understand. One of the most shocking hypotheses in current cosmology is the possibility of eternal expansion. If inflation could make our universe exist, it's possible it could continue forever. Brian Cox describes an incredibly vast inflationary multiverse, where universes are endlessly created and keep expanding. Imagine each Big Bang as a flare lighting another universe, while inflation continues in different regions, creating countless other universes. This cycle could, in theory, happen forever. This idea of immense universes gives rise to an intriguing concept of a fractal universe, where each new universe could actually create its own Big Bang. Each universe exists as a separate, independent space, unaffected by the others due to the rapid expansion of space. For scientists, this speculation is both exciting and disturbing, as it suggests an endless multiverse with no definitive start or end. Imagine our universe being just a small part in a massive, infinite structure, ever expanding and continually creating new universes. And what if the disturbing truth is that there is no before or after, but instead an eternal cycle of universes forming and decaying? How we interpret nothingness changes when we consider quantum field theory. According to this theory, the universe isn't a collection of matter floating in space. It's a complex network of energy fields that permeate the universe, interacting to create everything we observe. These fields resemble invisible oceans, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and vanish in these fields instantaneously, gaining energy before returning it. This phenomenon leads to virtual particles, entities that briefly exist and then vanish, leaving only a faint memory of their presence. The idea of virtual particles challenges the notion of a true void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have absolutely nothing? According to quantum field theory, you wouldn't. Even in a vacuum, fields would remain active, sometimes generating transient particles. This constant movement in what should be nothing suggests that the universe does not recognize our idea of emptiness. The fields and forces persist, filling the universe with a mysterious energy that prevents absolute nothingness. This raises an intriguing question. If fields create particles, and particles make matter, could the universe itself have arisen from this nothingness, filled with quantum fields? Dark energy is a mysterious force that currently drives the accelerated expansion of our universe. But did dark energy exist before the Big Bang? From certain perspectives, the fact that dark energy exists today is a leftover energy field from before our universe's formation. The properties of dark energy seem to suggest a deep secret power that could have existed in a form prior to the Big Bang. Some theories propose that dark energy, in a much stronger state, may have governed the inflationary phase, causing rapid growth. The existence of dark energy suggests that, whether or not our universe were depleted of all matter and radiation, this force would continue to stretch the fabric of space-time. This idea leads to a disturbing question. If dark energy was present before the Big Bang, could it have set the conditions that led to the birth of our universe? Could dark energy be the silent architect of inflation, or even the true beginning of our universe? As we explore this possibility, we face the potential of dark energy not only as a force shaping our universe, but also as a key that could unlock the secrets of the multiverse itself. Another hypothesis that offers an alternative to the Big Bang as the ultimate beginning is cyclic cosmology, the idea that the universe undergoes infinite cycles of birth, death, and rebirth. In this model, the Big Bang is not a one-time event, but part of an eternal rhythm where universes grow, collapse, and then emerge anew. This hypothesis suggests that our universe could have been reborn from the remnants of a past universe. The process of contraction and expansion in a cyclic pattern would mean that there was never a true beginning, but rather a timeless series of universes emerging, growing, and rejuvenating themselves over and over again. Cyclic cosmology raises profound questions about time itself, suggesting that time may be repetitive rather than linear. If this hypothesis is correct, it could imply that what existed before the Big Bang was simply another version of the universe, one that collapsed only to give birth to our current universe. For scientists, this theory offers a rich answer to the question of what existed before the Big Bang. Cyclic cosmology offers a fascinating and challenging view of the universe's origins. If time is indeed cyclical, then our current universe could be just one iteration in an eternal loop, constantly cycling through phases of creation and destruction. This idea removes the necessity of a singular beginning or end, and instead suggests that the universe has always existed in some form, with each cycle beginning anew after the previous one collapses. It suggests that the Big Bang wasn't the beginning of time itself, but rather one event in an infinite chain of cosmic births. For scientists, this theory challenges the very notion of a linear progression of time and forces us to rethink the nature of existence. If the universe has always existed in a cyclical pattern, it questions our understanding of beginning and end, terms that may not apply to a reality where the universe simply continues to evolve, regenerate, and eventually collapse, only to be reborn once again. It presents the possibility that what came before the Big Bang was just another iteration of the universe in an endless loop of cosmic renewal. This cyclical model also ties into the idea of a bounce, a theory where the universe contracts to a point of maximum density before rebounding in another Big Bang. This concept, known as the Big Bounce, posits that each contraction is followed by a subsequent expansion with no true beginning or end, but rather a series of cosmic oscillations. If true, this could suggest that our universe is simply the latest in a long series of cosmic births, each resulting from the collapse of a prior universe. The idea of cyclic cosmology also raises the possibility that the universe we currently observe could have undergone multiple cycles of expansion and contraction, each phase leaving traces in the form of dark energy, quantum fields, and cosmic structures. These remnants might offer clues about the universe's past and the possibility of discovering other, older universes that existed before ours. This theory could potentially offer answers to some of the most profound questions in cosmology about the nature of time, the fate of the universe, and the forces that govern cosmic evolution. In addition to cyclic cosmology, the idea of an eternal multiverse continues to capture the imagination of scientists and philosophers alike. The notion that our universe is just one among countless others, each governed by its own set of physical laws and constants, challenges our understanding of reality. If the multiverse theory holds, it could mean that what we perceive as the beginning of the universe, the Big Bang, is merely a local event within an infinite expanse of multiple universes. These universes could be born, evolve, and eventually collapse in parallel to our own, creating an endlessly complex and ever-expanding multiverse. The existence of such a multiverse would also call into question the role of our universe within the larger structure of reality. Are we just a tiny part of a vast cosmic ecosystem, or does our universe hold special significance within the multiverse? And if multiple universes exist, could there be others with different physical laws or dimensions of time and space? These questions open up exciting avenues for exploration, offering a glimpse into realms beyond our current comprehension. In exploring the possibilities of what existed before the Big Bang, we venture into the realms of the unknown, realms where the limits of human understanding are constantly being tested. Theories like dark energy, cyclic cosmology, and the multiverse challenge our assumptions about the nature of reality and the origins of the universe. As scientists continue to push the boundaries of knowledge, new discoveries may emerge that shed light on these profound questions. Whether through quantum physics, cosmology, or the study of dark matter, we are likely to continue exploring the deepest mysteries of existence. What existed before the Big Bang may never be fully understood, but the journey to uncover these truths may lead to a deeper understanding of our place in the universe. Each new theory, each new discovery, brings us one step closer to unraveling the grand mysteries of existence. The questions that remain about the origins of the universe, the nature of time, and the potential for other universes may never have simple answers. But in asking them, we continue to explore the vastness of reality and the infinite possibilities that lie beyond our current understanding. The quest for knowledge is unending, and as we journey deeper into the unknown, we may one day uncover the ultimate answers to the greatest questions of all. What came before the Big Bang, and what is the true nature of existing?